Hi guys, this is the first chapter of the new course Quantitative Aptitude and Reasoning. In almost all the competitive examination and test, the concept of Hcf and Lcm is present. One or more questions are to be asked in these examination about the concept Hcf and Lcm. Hcf is the abbreviation of highest common factor and Lcm is the abbreviation of least common multiple. So first we discuss HCF, that is highest common factor. Our definition of the highest common factor is this is uh, the highest common factor are to be found for two or more numbers. So this is the greatest or highest number that divides each of the given numbers completely. That is, there are no remainder after the division. There are two well-known methods for finding out the HCF of two or more numbers. First method is called split method or prime factorization method, and the second one is known as division method. So in the split or prime factorization method, first of all we have to find out the prime factors of each of the given number. Then after that we are taking out all the common factors, all the common prime factors of these given number and to multiply them in order to find out HCF. Uh, let's take the first example, HCF of 84 and 90. So the prime factors of 84 are 2 and 2, 2 and 2, 3 and 7, and the prime factors of 90 are 2, 3, 3 and 5. Okay, this is very easy to find out the prime factors of any number. I find out the prime factors of 84. So for that I have to write it like this. Now 84 is divisible by 2. So 2 4s are 8, 2 2s are 4. Again it is divisible by 2. So 2 21s are 42, and then by 3 and 7. So 2, 2, 3 and 7 are the prime factors of 84. Similarly, we can find the prime factors for 90 by like this. 90, now here is 0 is in the end, so we divide it by 2. 2 4s are 8, 1 is the remainder, 2 5s are 10. Now at the last we have 5, so it's not divisible by 2, so let's try by 3. So 3 1s are 3 and 3 5s are 15, so it's divisible by 3. So 3 15s are 45, and again 3 5s are 15. So these are the prime factors of 90. So among all these prime factors, 2 is the common in each of these factors. Now for 84 we have 2 in the above line, but the 90 has no other the factors 2, so we eliminate this 2. Now 3 is present in the first row as well as in the second, so we take it, and 7 and 5 are come once, so these are to be eliminated. So the required HCF will be 2 multiplied by 3, which gives us 6. So this is the required highest common factor. Now in the second example we are asked to find out the highest common factor of three numbers, that is 1365, 1584 and 1872. So first of all we have to find out the prime factors for each of these given numbers. So the prime factors for 1365 are 3, 5, 7 and 13, and for 1584 is the product of factors 2, 2, 2, 2, 3, 3 and 11. 2 4 times, 3 2 times and 11 once. And for 1872 the prime factors are 4 times 2 and twice comes 3 and then 13. Now the common factor among all these three lines is only 3, because 3 comes in the first line as well as in the second and in the third. But if we compare 5, so 5 present in the first and not in the second and the third, 7 present in the first list, not in the second and the third list. Similarly, 13 present in the first and the last list, but not in the product of 1584. So the required highest common factor is only 3. Similarly, we can find out the Hcf of 792, 1155 and 16 in the example 3 by the prime factorization method. That is 792 has the factors 2, 2, 2, 3, 3 and 11. 1155 has the factors 3, 5, 7, 11 and 1716 has the factors 2, 2, 3, 11 and 13. Now the common factors is 3 is present in all of these 3 lines. Yes, it is present. Also 11 is present, but 2 is not present in all the 3 products of factors. Similarly, 13 is also not present. So we only take 3 into 11 and its product is 33. So the required highest common factor of 792, 1155 and 1716 is 33. Now let's try the second method, division method. In the division method, first I try to clear your concept about the division of two numbers. If we are given a number 9 and we are asked to divide it by 3, so the number 9 is known as dividend, 3 is known as the divisor, and here to multiply with another number to reach with 9, so this 3 is known as quotient, and here is the remainder. So your division has 4 parts: dividend, divisor, quotient and remainder. So if you know all these terms, so it will be easy to divide two numbers and find out its highest common factorization. So by division method, to find out the highest common factor is very easy. If we are given two numbers, so we will divide the highest number by the lowest number. That is in the first example 7. Now we are given two numbers 84 and 96, in which 96 is the greater than 84. So we divide 96 by 84. So 96 here is the dividend and 84 is the divisor. So in order to divide 96 by 84, we multiply 84 with 1, we get 84, and then subtract 84 from 96, we get 12. Now for finding out Hcf, we again divide the divisor by the remainder, and then this process will be continuous up till we get the divisor. The remainder is 0. So 12 7s are 84, we get the remainder 0. So the required highest common factor will be the last divisor. So the last divisor after the remainder is 0 is the given highest common factor. Okay, here in the example number 8, we are asking to find out Hcf of 1672 and 374 by division method. As 1672 is greater, so we divide it by 374. So 374 4s are 1496. We get the remainder 176. Now the divisor will become dividend and the remainder will become divisor. We get 352 and the remainder is 20. Now multiplying 20 with 8, we get 160 and the remainder is 16. So the divisor become here dividend and the remainder is divisor. We get again 16 ones are 16, remainder is 4, and 4 4s are 16, remainder is 0. So the last divisor here is 4. So the required highest common factor is 4. Similarly, in the 9 example, we are given the number 3672 and 2496, and we are asking to find out its highest common factor. So the greatest number is 3672, and if we divide by 2496, we get the required highest common factor is 24. Okay, similarly, in case of more than two numbers, we can also find out its Hcf by the division method. So for that, we are taking any two numbers and find out its highest common factor. Like in this case, we take the number 1461 and 1266. So its Hcf is 3. Now we are taking the Hcf of 3 with the remaining number 1863. So after multiplying 3 with 21 we get 1863 and the remainder is 0. So the combined required highest common factor is 3 in this case. So this is the intro about Hcf by two well-known methods, prime factorization method and division method. And I hope you people learned this concept very well, and I also explained it with practical examples. Now we are starting the another concept, LCM. But before starting LCM, let's have a short view of Hcf of decimal numbers. So for the decimal number Hcf, it's not so difficult. Like in this example number 15, we are asked to find out Hcf of 25.5, 42.5 and 170. Now in 170 we have no decimals, but in the first two numbers 25.5 and 42.5 we have decimals. So the point in order to find out Hcf of decimals, first we have to multiply the decimal numbers with some appropriate numbers to get the three numbers or more numbers and same and without decimals. Now in order to eliminate decimal from first and second number, we have to multiply it with 10. So after multiplying with 10 we get 255, 425 and 1700. Now we are three other numbers without decimals. So the required Hcf of these three numbers 255, 425 and 1700 is 85. But we multiplied before it by 10. So the required answer will be now we divide it by 85. Because multiplication and division are opposite to each other and they cancel the effect of each other. So the required Hcf will be 8.5 because we divide 85 with 10. Okay, in the example number 16, we are required to find out Hcf of 36.54, 48.42 and 58.41. Now we are given three numbers and all these numbers have decimals. In order to eliminate the decimals, we have to multiply each number with 100. Like 36.54, if we multiplied it with 100, we get 3654. Similarly, if we multiply 48.42, we get 4842 and 5841. Now these are three numbers, integers without decimals, and Hcf will be 9 is by division or prime factorization method. So the required Hcf is 9, but actually in the previous we multiplied the decimal numbers by 100. So the required answer will be divided by 100. So 9 by 100 gives us 0.09. Similarly, in example 17, we have the number 78.9, 165.6, 376.2. So multiplying it by 10, we get the numbers 789, 1656, 3762. And after division, we get the Hcf is 3. And by dividing it by 10, we get 0.3. Now there is another concept. If we are given fractions and we are asked to find out its highest common factor, so first to find out the fraction of two or more than two fractions, we mean that it is the highest fraction by which each of the given fractions will be completely divisible. So for that we have to find out the lowest terms of each fraction, that is of the numerator and as well as by the denominator, and after that we have to apply the formula for Hcf of numerator and Lcm of denominator. That is, if we are given the fraction, so our first step will be to shorten it, to write it in the lowest terms, to divide it if it is possible, and after that we have to find out Hcf of the numerator and then Lcm of the denominator, and then the required number will be the Hcf of the given fraction. For example, in the example number 19, we are given the numbers 3 fraction 63 by 9, 5 whole 6 by 17 and 42 by 51. So 63 by 9 can be further simplified into the lowest terms 7 by 1. 5, 6, 17 can be written as 91 by 17 and 42 by 51 can be written as 14 by 17 because it is divisible by 3. Now the given fractions are 7 by 1, 91 by 17 and 14 by 17 after the reduction into lowest terms. Now in order to find out its Hcf for the given three simplified fractions, so we take the Hcf of the numerator number, that is 7, 91 and 14, which is 7, and we have to find out the LCM of the denominator number, that is 1, 17, 17, which is 17. So the required highest common factor for the given fraction is 7 by 17. So I think you people learn the concept very well for the whole numbers as well as for the decimals and fractions. Now we are moving towards that how to find out the LCM. Okay, LCM is the abbreviation of least or lowest common multiple. So first, what is common multiple? A common multiple of two or more number is a number which is exactly divisible by all the given numbers. An LCM of the two or more given number is the least number which is exactly divisible by all the given number. For example, 35 is the common multiple of 5 and 7, same 70 and 105 are also common multiples of 5 and 7. But in all of these, 35 is the least common multiple of 5 and 7. Okay, in order to find out the LCM, we have two methods, same as like we have used for HCF. So for this we also have two methods, prime factorization method and division method. So by using prime factorization method, we have to find out the prime factors for each of the given numbers, that is for 12, 16, 21 and 36 separately. Okay, so we have resolved the given numbers into prime factors, and then we have to take the product of the highest power of all the factors, and this product will be the required LCM. So we separately take the prime factors of all the given numbers and then the highest power of all the factors, and their product will give us the required LCM. That is, in the example number 25, we are given the numbers 12, 16, 21 and 36. Four numbers are given and we are asked to find out its LCM. So the prime factors of 12 are 2, 2 and 3. So 2 power is 2 and 3 power 1. Similarly for 16 we have 2 power 4 and 21. The prime factors are 3 power 1 and 7 power 1. And for 36 we have 2 power 2 and 3 power 2. Here in all these prime factors are 2, 3 and 7, and their highest powers are 2 power 4, 3 power 2 and 7 power. This is the highest 2 power 4, because in the first line we have 2 power 2, here is 2 power 4, and in the last we have 2 power 2. And 3 power 2 is the highest, because in the first we have 3 power 2, here is 3 power 1. So 3 power 2 is the highest. Similarly we have 7 power 1. So the highest powers are 2 power 4, 3 power 2 and 7 power 1. So after taking the product of all these powers, we get 1008. So 1008 is the LCM of 12, 16, 21 and 36. Okay, let's try another example. We are given numbers 27, 36, 80 and 175. Prime factors for 27 are 3, 3, 3, 3 power 3. For 36 we have 2 power 2 and 3 power 2. For 80 we have 2 power 4 and 5 power 1. And for 175 we have 5 power 2 and 7 power 1. So the highest powers occurring in the given numbers 2 power 4, 3 power 3, 5 power 2 and 7 power 1 are 2 power 4, 3 power 3, 5 power 2 and 7 power 1. And after taking the product of all these powers, we get 75,600 as the required LCM. Okay, and now we try the LCM for the given asking numbers by using division method. So in order to find out LCM for the given numbers by using division method, first we write all the given numbers in a single line and separating it by commas, like this line we write 15 comma 18 comma 54 comma 135 comma 180, and starting divided by the lowest prime factor, that is 2. We have to start from 2, and to note that any two or more numbers, if they are divisible by 2, so we have to divide it, otherwise we have to start from 3 or from 7 and from the next prime numbers. So if we divide by 2, so 15 is not divisible by 2, so we just write it down as it is before. 18 is divisible, 2 9s are 18. 54 is divisible, 2 27s are 54. 135 is not divisible, so we write it is, and 180 is divisible by 2, so we write 2 90s are 180. Now one number in the R list 15, 9, 27, 135 and 90 is divisible by 2, so we not going for only one number, so we try another 3 number. So most of the numbers are divisible by 3, so we get 3 5s are 15, 3 3s are 9, 3 9s are 27, 3 45s are 135 and 3 30s are 90. Again dividing it by 3, so we get 5 is not divisible by 3, so 5 in the same place, 3 1s are 3, 3 3s are 9, 3 15s are 45 and 3 10s are 30. Now dividing it by 5, 5 1s are 5, 1 remains the same, 3 remains the same, 5 3s are 15 and 5 2s are 10. Again dividing by 3, 1 remains same, 1 remains same, 3 1s are 3, 3 1s are 3 and 2 remains same, and in the last by 2, so 2 1s are 1 1 1 1 and 2 1s are 2. So the required LCM will be all the given factors, the product of all the divisors will be the required LCM. That is, we have to multiply all these divisors and remainders. So 2 into 3 into 3 into 5 into 3 into 2. So we get 2 square, 3 cube and 5, which gives us 540. So the required LCM by division method for the numbers 15, 18, 54, 135 and 180 is 540. Similarly, in the example number 29, we are given the numbers 18, 32, 72 and 96. We are given these numbers, so first I write all these numbers: 32, 72 and 96. So all these numbers can be divided by 2. So after division we get 2 9s are 18, 2 16s are 32, 2 36 are 72 and 2 48s are 96. Then by 3 3 and 2 2 2 we get the required divisors are 2 2 3 3 2 2 2 and then 1 1 1 and 1. So after multiplying all these products we get 288. This is the important MCQs and important note for all of you to have in your notebooks. The product of any two numbers will be equal to the product of their HCF and LCM. What does it mean? Well, if we have two numbers A and B, so the product of these two numbers will be equal to their highest common factor and lowest common multiple. That is, if we have to find out the HCF and LCM of these two numbers and multiply them, so it will give the product of these two numbers. Right? Okay. Similarly, we have to find out LCM of decimals. This is the same method as we have done for HCF, and the first step we have to convert the decimal numbers into equivalent integers or whole numbers. Then after that we have to take out the LCM of those whole numbers, and in the last we again convert the whole number into the digit by the respective multiples of 10 or 100 or 1000, as so you have applied before, right? I try one example number 30. We are asking to find out the LCM of 0.8, 0.9 and 0.36. So 0.8, 0.9 can be written as 0.80, 0.90, and 0.36. After this we have to multiply it by 100, we get 80, 90 and 36, and LCM of these number is 720, and after that we have to divide it by 100, so the required LCM is 7.2. Similarly for LCM of fractions, so the LCM of two or more fraction is the least fraction or integer which is exactly divisible by each of them. So for the LCM of fraction we use the formula LCM of numerator by Hcf of denominator. It is opposite of that of Hcf. For Hcf of fraction we use Hcf of numerator divided by LCM of denominators. We have to take Hcf of numerator and LCM of denominator. This is for Hcf. But for LCM we use opposite of it, that is we have to find out LCM of numerator then Hcf of denominator after simplification of the fractions. It is in the example number 33 part first we are given the numbers 2 by 3 and 6 by 7. So 2 by 3 and 6 by 7 are in their reduction simplification state and in the lowest terms. So in the numerator we have the numbers 2, 6, and in the denominator we have the number 3, 7. So as per the formula we have to find out LCM of 2 and 7, that is of the numerator numbers, which is 6, and Hcf of 3 and 7 which are in the denominator. So the Hcf of 3 and 7 is 1. So after dividing 6 by 1 we get 6. So dears, in this presentation you learnt about Hcf and LCM, the important concept of quantitative aptitude. We learnt how to find out Hcf of the whole numbers, decimals and fractions by prime factorization and division method. Similarly for LCM we discussed the two methods, prime factorization and division method. Also we learned how to find out LCM of decimals and fractions. I hope you learned these concepts well. Thanks a lot for taking your precious time. Please like my video and share it with your colleagues. Also subscribe my channel. Goodbye.